Hello students, I am Dr. C. Thamarai Chelvi, Associate Professor of Chemistry, the Standard Fireworks Rajaratnam College for Women, Sivagasi. In this video, we are going to discuss about ionic bonds and ionic compounds. These are the learning objectives of this video. First we will see the introduction part. Next, I will see the definition of ionic bond and the examples, a few examples of ionic compounds. And then next summarize what we discussed in this chapter and then recall the concepts of ionic bond and ionic compounds. Okay. Before enter into the topic, first we will see the basic concepts of the atoms and the atomic numbers. Okay. Already we know what is meant by atom. Atom is a very small invisible particle. It contains protons, neutrons and electrons. Proton having positively charged particle, there is no charge for neutrons, and then this both protons and neutrons are present in the nucleus, the compact structure, and then around the nucleus the electron is spinning. Okay, this is the structure of atom. Can you guess which atom is given an example? See, in this atom there is 2 protons and 2 electrons are present. So, the atomic number of an atom is 2. Can you guess? Yes, this is the helium atom having the atomic number 2. Okay. Next, these are the few examples of various atoms having the electronic arrangement. First one, hydrogen atom. Hydrogen atom, the atomic number of hydrogen atom is 1. Do you know about the definition of atomic number? Everybody studying in the lower classes. Atomic number is number of protons or the number of electrons present in the atom. Okay. First we will take a hydrogen. The atomic number of hydrogen is 1. That is, how many electrons are present in an hydrogen atom? Only 1 electron. Okay. There is a possibility for neutrons present in the nucleus? No, definitely no, there is no neutrons present in the hydrogen atom. Okay. Next element, carbon. Here how many electrons are present in the carbon atom? You yourself count the number of electrons present in the carbon atom. Okay. The total number of electrons present in the carbon atom is 6. Okay. The first cell, it can hold only 2 electrons, and then next cell is the outermost shell. That outermost shell is called as a valence shell. It can hold 8 electrons. Okay. Similarly, nitrogen and oxygen. Now have entered into the topic ionic bond. Okay. First we will see the definition. Now let us explain how the ionic bonds are formed. First see the definition, the complete transfer of electron from one atom to another atom, that is called ionic bond. The electron completely transfer from one atom to another atom, that is called ionic bond. It is also called as electrovalent bond. Okay. See the example, sodium. The atomic number of sodium is 11. The electronic configuration of the sodium atom is 1s2, 2s2, 2p6, 3s1. Okay. So here the outermost shell contains only 1 electron. It is readily to lose 1 electron to attain the stability. Okay. According to the octet rule, it willing to donate electron to the other atom. Okay. Next, see the chlorine. Chlorine, the atomic number of chlorine is 17. See the atomic structure of chlorine. The electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Okay. The outermost shell contains 7 electrons. That 7 electrons leads to instability of the chlorine. So, it needs 1 electron to attain the stability, that means to attain the octet electronic configuration. Okay. So, the sodium is a metal, chloride is a non-metal. So, the metal willing to donate electron, non-metal willing to accept the electron. Okay. So, sodium willing to donate 1 electron to the chlorine, chlorine accept 1 electron to form a chloride ion. After formation of ions, it also unstable. So, these two atoms are fused together to form a ionic bond. Okay. So, the transfer of one atom to the another atom form a ionic bond. Are you clear? Okay. Now, we will see the periodic table. In this left side, hydrogen period or the first period, see lithium, sodium, potassium, rubidium, cesium, francium. These are metals. And then in the right side, see the 7th group, fluorine, chlorine, bromine, iodine. These are non-metals. So, this group 1, see the periodic table. Then this periodic table, the first group, hydrogen. Under the hydrogen, lithium, sodium, potassium, rubidium, cesium, francium elements are present. All the elements are metal. See the right side, in the 7th group, all are halogens. These are non-metals. That is fluorine, chlorine, bromine, iodine, all are non-metals. So, the first group and then 7th group interact to form a ionic bond. Likewise, see the second group. Second group contains beryllium, magnesium, calcium, strontium, barium and radium. In the 6th group, see the 6th group, the right, before the 7th group in the right side, see oxygen, sulfur, selenium, tellurium, polonium, all are non-metals. This group 2 elements are willing to donate 2 electrons to the non-metals present in the 6th group. That 6th group oxygen, sulfur like elements are accept 2 electrons from the metals. These two are form ionic bond. These are then example for ionic compounds. Here the sodium is present in the first group, chlorine is present in the 7th group. These two are sodium willing to donate 1 electron to the chlorine, chlorine accept 1 electron coming from the sodium. It fused together to form a sodium chloride. Likewise, the magnesium is present in the group 2. Here oxygen is present in group 6. These two are fused together to form a ionic compounds, magnesium oxide. That magnesium willing to donate 2 electrons to the oxygen. Oxygen accept 2 electrons to these two are fused together to form a ionic compounds. Likewise, lithium fluoride. These are the basic idea about ionic bond and ionic compounds. Now, we will summarize what we studied in this module. First, an ionic compound is the force of attraction that holds together positive and negative ions. It often forms when atoms of a metallic element give up electrons to atoms of a non-metallic element. So, metals and non-metals combine to form a ionic bonds. Okay. The next, ionic bonds form only between the metals and non-metals. That is because metals want to give up electrons and non-metals wants to gain electrons. Next, it takes energy to remove valence electrons from an atom and form a positive ion. If you take metals like sodium, during the ionization energy process or the electron removed from the outermost shell, the energy is required to remove the valence electron. Okay. After removing, it form a positive ion. The next, the energy is released when an atom gains valence electron and form a negative ion. Like chlorine, chlorine has a tendency to accept electron. During the acceptation of electron, energy is released. It form a negative ion. Okay. The next, recall the concept. What happens when an atom gains an electron and becomes a negative ion? What do you think about that? Do you know? Okay. Energy is released when an atom gains an electron. Like halogens release the most energy when they form chloride ions. As a result, they are very reactive elements. Thank you for watching this video. Let us see in the next video.